Regarding the security plan of this whole fintech system design, these are a few of the points we need to keep in mind. There will be dedicated backups along with which we discussed the disaster recovery plans. Obviously, that also includes the security plan along with it as well. So we will be properly doing these of the steps, and these are not the whole. There will be some additional things as well which we need to consider at the infrastructure level, at the application level, that how we will be properly protecting our data during at rest, during transit, what will be the protocols which we will be using. So first of all, here is the implementation of a proper multi-factor authentication and two-factor authentication. Whenever user will be doing the will be handling the login request from the authentication services. So here this whole multi-factor authentication and two-factor authentication will be done within the auth backend microservice. So as we are not going right now into the low-level design of the auth, so but the main thing is that it will be the responsibility of the auth to handle the complete MFA and 2FA, along with the sending of the OTP codes will be the responsibility of the notifications microservice. And these two microservices will be communicating with each other directly via notifications API call to properly send the OTP code to the user successfully. And then obviously at when the data will be in transit, then we will be using TLS, transport layer security, or we can also say that secure protocol SSH to so that data cannot get leaked during the movement. And also during at rest, we need to properly encrypt the data using the protocol like AES 256 that we can do using that we need to do at the primary SQL database server, and then at the secondary, and then also in all of those read replicas present. And also same goes with the Redis cache and the Apache Kafka. Normally in the Apache Kafka, there will not be that much data present normally because we are just using the PubSub architecture for Apache Kafka. So it will be having some events present like the event IDs and the event titles and then the target consumer backend microservice. But there will be some sensitive data present as well, which we need to properly encrypt so that during any disaster recovery or leakage region situation, user cannot properly read that data. And then on the edge delivery, we also need to consider that because there will be some static secure content that user can access at the edge delivery level, like internal admin portal stakeholder staff will be pushing some data, some sensitive documents to the blob storage here. And that I have not communicated here properly using any arrow, so I can do that in this way. So, but that blob storage will be public, but it will be the using with the implementation of some verification of some tokens and signed URLs. So that URLs will be public, but still not everyone can see those sensitive data. We can properly categorize that some documents will be public for the whole, like let's say an example of documentation of how to use our mobile app. That will be public, and that will not include any authentication, any signed URLs. But like the electronic statement or monthly statement of user, that is a secure document. That will be still present in the blob storage, but in this case, we will not be using any. We will be using some authentication, and same it goes at the application level as well. Like we know normally whenever user wants to see its electronic statement, PDF is also properly saved with the password, and user first needs to enter the password to properly open the PDF. But at the same goes at the infrastructure level, we need to properly secure the electronic statements or whatever the PDF we are using. That is also very important aspect while implementing the security plan for the user. And also there will be some public components will be there, and then there will be some private microservices there, like database and backend microservices will be present in private VPC. It doesn't matter if we are using AWS, we are using GCP or Microsoft Azure. Private VPC concept is present in all of them, and all of the backend microservices databases will be in the private VPC. But and same goes with internal admin portals. This microservice is the front-end microservice, but still because it is only accessible by the staff members, so that will also be present in the private VPC. But about this public web portal, if we have a functionality that user can properly access its account from the browser, then this web portal will be the public one. And same goes with obviously with the mobile app, because user can download it from the Play Store or from the App Store, so it will also be public. So properly categorization of the components, that which will be the public ones and which will be the private ones. We will need a proper plan for this. At the application levels, we will also be implementing the proper security groups present, so that we will be using the least ports which user can access at the machine level. Same goes with the access tokens and refresh tokens present. Our authentication service will be properly using the tokens validation, and we will be storing that tokens at the Redis store. But the normal time of expiry time of these access tokens will be very minimal. And after those tokens will become invalid, and user needs to log in again, or we will automatically issue the refresh tokens in this case. We can also create a separate dedicated fraud detection service. This is mostly related to the business logics to properly implement the anti-money laundering related security implementations we can, and also the centralized logging. We have also discussed this idempotency, that each of the backend microservices, all of the APIs will be properly idempotent so that we can properly implement the retries. If any our request fails, then we can properly try the retry logic with the help of add letter queues. At the infrastructure level, all of the cloud providers like AWS, GCP, or Microsoft Azure, they also provide the support for key management systems or the hardware security modules. So we can use that for all of the internal staff members as well. And same goes with the app level security. At the app level, we need to properly make our APIs safe with the help of different mechanisms. Like we'll be properly doing the validation of our inputs. We'll be properly doing the saving our APIs from our data from SQL injection, from cross-site scripting, and from request forgery request. So, and also from the bot attacks. At the API gate level, we are properly implementing the rate limiting and rate throttling. So whenever there will be any bot attacks, there will be any CSRF attacks, this API gate level, its responsibility will be to properly handle those attacks.